Okay, so here's our section on scientific notation. If what I've been saying about scientific notation throughout this lecture has been confusing, then I would listen up to this portion. So, in scientific notation, a number is written as y times 10 raised to the x. Y is called the coefficient and is any number between 1 and 10. The term x is an exponent, which can be any positive or negative whole number. And this exponent tells us how many decimal places we have moved our decimal from our original number. So this notation tells us how we can go from a small number or a really big number and write it in a more simpler way. So there's two steps that you want to worry about with scientific notation, so let's practice those. Here we have 2,500. Our first step that we want to do is to move the decimal place to give us a number between 1 and 10. So our decimal place is right here. So we are going to move it one place. If I do that, then I have 250.0. That's not a number between 1 and 10. If I move it another place, that gives me 25.00. That's not a number between 1 and 10. If I move it a third time, that gives me 2.5, which is a number between 1 and 10. So we could stop there, but just to show, if I were to move it another time, that would give me 0.2500, which is less than 1. So it does not fall between 1 and 10. So we move our decimal place to give a number between 1 and 10. So that's 2.500. Next up, we multiply the result by 10 raised to the x, where x is the number of decimal places moved. So we're going to do 2.500 times 10. And we're looking at x now. How many times did I move my decimal place? Well, I did 1, 2, 3. So my x value would be 3. Let's do another one. So I have 0.036. So I already have my decimal place in there. So I'm going to move my decimal place now to the right, because if I moved it to the left, I get 0.0036, which is even smaller than the number I had originally, which was already less than 1. So we're going to move this one place to the right. That gives me 0.36. That's still less than 1. We're going to move it a second time, and we're going to get 3.6. That is a number between 1 and 10. But again, just to show, if I moved it a third time, that would give me 36, which is greater than the value of 10. So we move the decimal place 2 times to get 3.6. Our second step is to then multiply the result by 10 raised to the x, where x is the number of decimal places moved. So we have 3.6 times 10, and we've moved it twice, but because we got smaller, or because we went to the right, because we're using a small number, we have to put a negative in our 2. That negative tells me that I move my decimal place to the right, whereas on my other one, because I move my decimal place to the left, it's a positive number. Let's make some rules. So if we move the decimal to the left, the variable x must be positive. If we move the decimal to the right, the variable x must be negative. So Let's practice that with a few extra problems. So for each of these values, convert them to scientific notation and then give them 3 significant figures. Let's see, can I move this? Let's move down so we can zoom in. Okay, so we have 93,200. So my decimal is here. We're moving it 1, 2, 3, 4 places to get 9.3200 times 10 to the 4. So I moved it so my decimal place was making a number between 1 and 10. That number of times I moved my decimal was 4. So we get 9.3200 times 10 to the 4. Now I want this to have 3 significant figures, so these zeros at the end are going to go away because I'm just essentially going to be rounding. So this would be 9.32 times 10 to the 4. Next up, we have 0.000725. So I'm moving my decimal place 1, 2, 3, 4 places. This time I'm going to the right, so I know my times 10 is going to be negative, and it's going to be 4 because I moved my decimal place 4 times, which gives me 7.25 times 10 to the minus 4, which already has 3 significant figures in it. Okay, our next example is 6,780,000. We're taking our decimal and we're moving it 1, 2, 3, 4, 5, 6. So I have times 10 to the 6. Because I moved it 6, it's positive because I went to the left. And then with 3 significant digits, it would be 6.78. Okay, you try the last 3 independently, so pause the video and try those last 3 problems on your own. Our answer for D would be 3.00 times 10 to the minus 1, 2, 3, 4. 1, 2, 3, 4, 5. We then have 4.52 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Positive 12. And finally, 2.80 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Negative 11 because we're going to the right. Okay, so those are all of our values converted to scientific notation, each having 3 significant figures. Now, when we're converting a number that's already in scientific notation back to its standard form or its whole number form, we're going to follow those same 2 rules about our decimal place. If we see that the exponent is positive, we are now going to move our decimal to the right to compensate for the fact that it was moved to the left to make it scientific notation. Okay, so we're now doing the opposite because what we're doing in these problems is now the opposite of what we were doing before. So 2.80 times 10 to the 2 is, I'm going to move this now to the right because it's a positive number. So we're going to go 1, 2 decimal places to the right. So this gives me 280. And I'm going to put a point on there just to show my decimal place. So because now I'm going from scientific notation to standard form, my exponent rules are swapped. Whereas before, when I was going from standard form to scientific notation, we moved the decimal to the left and showed it as positive. And if we went to the right, we showed it as negative. So now we are swapping those. So you have to be careful about what way you're transferring scientific notation to standard or standard to scientific notation. If the exponent is negative, then move the decimal to the left. So I'm going to take 2.80 and I'm going to I have it as times 10 to the minus 2. So I'm going to go 1, 2. I'm going to fill in that blank with a 0. So we have 0.0280 as our value now. Okay? So let's practice converting these values from scientific notation to standard form. So we have a positive 3, so we're going to move our decimal place to the right. Okay, so here we're taking positive to the right and negative to the left. Okay, so we're going to go 1, 2, 3, fill in our blanks with zeros. That would be 6,500. Here we have a negative 5, so we're moving it to the left, 5 spaces, 1, 2, 3, 4, 5. So that's our new decimal place. We're going to have a 0, a decimal, 0, 0, 0, 0. So this would be 0.0000326. Next up, another negative. It's 2, so we go 1, 2. There's my new decimal. Put a 0 out in front. We're going to fill in that blank with a 0, 0.03780. Now, if you wanted to check your work, if you wanted to make sure the number you wrote is the same as what you just converted it from, use your rules from when you went from standard form to scientific notation to check. So let's take 6,500. My decimal is here. 1, 2, 3 to make a number that is between 1 and 10. So we get 6.5 times 10 to the 3. Because now that I'm going from standard form to scientific notation, if I move my decimal to the left, it's a positive exponent. Okay? So we can always double check our work. Now pause the video and try these last ones on your own. For D, we have 1, 2, 3, 4, 5, 6, 7, 8. Right? 1, 2, 3, 4. 0, 0, 0, 0, 0, 0. Lots of zeros added on. 1, 0, 4. That's how many zeros? 6 zeros. 1, 2, 3, 4, 5, 6. Here we have a positive 6. So again, 1, 2, 3, 4, 5, 6. 1, 2, 3 extra zeros. You get 2, 2, 2, 1, 3 zeros after. And finally, we have a negative 10. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my new decimal place. Put a 0 out in front. 0.123456789 zeros. 4, 5. There we go. So that's going from scientific notation to standard form.